All right. Today we are on chapter 6 of your textbook. It is about the normal distribution. If you remember, last week we worked on the discrete probability distribution, and one of the examples of the discrete probability distribution that we explored was the binomial probability distribution. So the random variable x in the discrete probability distribution or in that binomial probability distribution was a discrete variable. Now, if the random variable is a continuous variable, then the distribution is called the continuous distribution, or the random variable is called the continuous random variable. And one of the examples of continuous distribution is the normal distribution, which we are exploring today. First, let's talk a little bit about normal distribution. If a random variable has a probability distribution whose graph is continuous, not discrete, at this time, we are talking about continuous. If the graph of the probability distribution, okay, if the graph of the probability distribution is continuous and the shape is bell-shaped, symmetric, it is called the normal distribution. We talk about the bell-shaped or symmetrical graph in chapter 3. It is the same thing. It is the graph of the continuous random variable, and it's called the normal distribution. And the graph is called the normal distribution curve. Okay, name of the graph is the normal distribution curve. The one shown here is the normal distribution curve. In normal distribution curve, along the x-axis, we'll have the random variable, which is the continuous random variable x. Along the x-axis, we'll have the continuous random variable x. And along the y-axis, we have the probability distribution function. Along the y-axis, we have the probability distribution function, f of x. So this graph here is the graph of the normal distribution. An equation for the normal distribution looks a little crazy. This is the equation. So this equation is the graph of that, is the equation of this graph. F of x equal to, look at this crazy equation, f of x equal to 1 over the sigma, that is the standard deviation, times the square root of 2 pi multiplied to e raised to negative half x minus mean over sigma quantity squared. You don't have to memorize the equation, but this is the equation for this curve. What we already know from previous chapter or chapter 3 is this: x minus mean over sigma, which is a quantity inside the parenthesis, is the z squared. Because if you remember, z is equal to x minus mean over sigma. So if we replace this by z, then it will be 1 over sigma square root of 2 pi e raised to negative half. And in place of this, we write z squared. Z squared. So this is the equation of the normal distribution. Now let's talk about different types of normal distribution curve that is produced when there is change in the mean and the standard deviation. The first one here, same mean. You can see for these two curves, the mean is the same. Mean is equal to 0, same mean. But if you look at the standard deviation, for this taller curve, the curve which one is the curve which is tall, the mean is equal to 0 and standard deviation is 1. Whereas for the shorter curve, the standard deviation is 2. That means when standard deviation increases, the curve will be shorter. And also remember that this standard deviation produces vertical shift. So we can write that in our note catcher or add that in our note catcher. Sigma or standard deviation produces vertical shift. Produces vertical shift. That is, when sigma increases, the curve will be shorter. Okay, when sigma, that is standard deviation, increases, the curve will be shorter. It will be shorter. Now, if you look at the second case, this is the case when the mean is different. The first one has a mean of 0, second one has a mean of 2, whereas the standard deviation is same. For both, the standard deviation is 2. Because the standard deviation is same, the height is the same. But the sigma, the mean, mu, it produces the horizontal shift. When mean is equal to 0, the center of the curve is here. When mean equal to 2, the center of the curve is here. It has moved to the right. So we can say mu, or the mean, produces horizontal shift. Let's write that down. Mean produces horizontal shift. Mean produces horizontal shift. That means when mean increases from 0 up to 2, you can see when mean increases, the graph shifts towards the right. So let's write that down also. When mean mu increases, the curve will shift right. That means when it decreases, it will shift to the left. So that is how there is transformation in the graph of a normal distribution curve. Now let's quickly review the empirical rule. We studied empirical rule in chapter 3. It is the same rule again. So when your distribution is a bell-shaped or the normal distribution, then we can use the empirical rule for that distribution. And if you remember, the empirical rule says approximately 68% of the data values fall within one standard deviation. So if you want to see how much data is there within one standard deviation of the mean, then we have 68% of the data. So meaning of that is, if the mean is here in the middle, and if we go one standard deviation up and one standard deviation down, the amount of data that lies within one standard deviation is 68%. Similarly, you'll see that approximately 95% of the data value falls within 2 standard deviation of the mean. If you want to look at the amount of data within 2 standard deviation of the mean, that is 2 standard deviation up and 2 standard deviation down from the middle, then the amount of data that is here is 95%. Similarly, you'll see that approximately 99.7% of the data lies within 3 standard deviation of the mean. So if you want to go 3 standard deviation up from here and 3 standard deviation down from here, you'll see almost all data, 99.7% of the data that lies here within 3 standard deviation, you'll have 99.7% of the data. And this rule is called the empirical rule. And this is the exact same rule that we have explored in chapter 3. Now let's talk about the standard normal distribution. When we say standard normal distribution, is the normal distribution with mean 0 and standard deviation 1. So for a distribution like this one, if the mean, which lies in the middle, is 0, okay, if the mean is 0, mean equal to 0 and standard deviation equal to 1, mean of 0 and standard deviation 1, then we say that the distribution, in that case, the distribution is called the standard normal distribution. It is called the standard normal distribution. You can write this down, standard normal distribution. So for standard normal distribution, I can even write like this. It's a normal distribution with mean equal to 0 and standard deviation equal to 1. If the mean is 0 and standard deviation 1, that's called the standard normal distribution. And in standard normal distribution, along the x-axis, your random variable is the z-score. You will have z-score along the x-axis. your continuous random variable in this case is the z-score. So that is the standard normal distribution. Now, if the mean is not zero, the value which is there in the middle, the mean is not zero, mean equal to some value. Okay, if mean is not zero and standard deviation is not 1, in that case, this normal distribution, it is simply called the normal distribution. We just call it normal distribution. We are not saying standard normal. This is just the normal distribution. We call it normal distribution. And we may write like this: normal distribution with mean certain value and standard deviation certain value. And in this one, if it is not a standard normal distribution, in this case, along the x-axis, you'll have the continuous random variable x. You'll have the continuous random variable x. Now, if you have x along the x-axis, and if you want to find the z-score, we use this formula. Z is equal to x minus mean over standard deviation. So that is the formula to find z-score. This is the formula to find z-scores. Hold on. Z-scores when the x values are given. And if you simplify this, we'll get this one, x equal to mean plus z times sigma. This is the formula to find the random variable x when z-scores are given. So this is formula to find x when z-score is given. When z is given. The first one is the formula to find z when x is given. The second is the formula to find x when z is given. So when you know z, you can find x using the second formula. When you know the x value, okay, when you know the x value and if you want to find z, you use the first formula. You know the z and you want to find the second, you have to use the second formula. From z to x, the second formula. Okay, some properties of normal distribution now. Remember one thing, the normal curve, this curve here is a bell-shaped curve. The shape of the curve that you see here, it is called the bell-shaped curve. Always for normal distribution, the shape of the curve is bell-shaped curve. And here in the middle of the normal curve, in the x-axis, here is your mean, but also you have the mean, median, and mode. They are all equal. That means here in the middle, you'll have the mean, you'll have the median, and also you'll have the mode for the normal distribution. We already know the third property from chapter 3. The curve is symmetrical about the mean. That is, if you fold this curve along this line, then this part of the curve over this, the right part of the curve lies over the left part of the curve, or the shape of the curve to the left and right of this line is exactly the same. That's why it is called the symmetrical curve about the mean. Next property, you can see that this curve decreases on the left. It gets closer and closer to x-axis, but in reality, it will never touch x-axis. Whether you go to left or right, the curve will never touch x-axis. And one very important property is if you add the total area, or if you find the total area under this curve, the total area under this curve is always 1. The total area under the curve is always 1. Because the total probability is 1 and total area under this curve is also 1, we use this curve to find the probability of the normal distribution or the continuous random variable. That's why the function which models this curve is also called the probability distribution function, because the area under this curve is 1, like the total probability is 1. Example, find the area under the normal curve. So finding the area under the normal curve, we have the example here. Find the area under the standard normal distribution. You can see here it's talking about the standard normal distribution. We already know for the standard normal distribution, mean is equal to 0 and standard deviation is equal to 1. That is the standard normal distribution. And we want to find the area under the curve under these situations. So whenever you have to find the area under the curve, try to remember this. This is what you're using in your calculator. Area is equal to normal CDF, normal cumulative distribution function in your calculator. And then inside the parenthesis, you'll use the lower value, you'll use the upper value, and then you'll use the standard, lower value, upper value, mean, and the standard deviation. This is the special command that we'll be using in our TI-84 calculator to find the area under the normal curve under each of these situations given here in A, B, and C. So that's like a formula. For part A, let's look at part A. We have to find the area between z equal to negative 1.03 and 1.64. This is the standard normal distribution, meaning of that is in the middle you have the mean, which is equal to 0. So mean in the middle is 0. And because this is the standard normal distribution, along the x-axis you have the z-score. Now we want to find the area between z equal to negative 1.03. Negative number will be on this side, so negative 1.03 should be somewhere here. So let's say this is z equal to, this point is z equal to negative 1.03. Okay, from here up to z equal to 1.64. 0 is here, so 1.64 is somewhere there. So that is z equal to 1.64. We want to find the area between these two values. We want to find the area between these values. Between these two values. So we want to find that area. We want to find that shaded area. Let me write A for that area. So we want to find that area A between z equal to negative 1.03 and z equal to 1.64. So what do we do in our calculator in order to find that area is area equal to area A is equal to, we are going to use this function, normal cumulative distribution function in our calculator, normal CDF in our calculator, lower limit. So for this area, look at the screen, for this area, the lower boundary is negative 1.03. So negative 1.03. Upper boundary, the area goes from here all the way up to here, which is z equal to 1.64. Then we need the mean for the standard normal distribution. Mean is 0. And the standard deviation sigma, that is equal to 1. So we are going to type this in our TI-84 calculator to get this result. Now I'm going to show you how we can type this in our TI-84 calculator. Okay, in our TI-84 calculator, we go to second, and then we go to vars. Here is vars, V-A-R-S. Because by pressing second and vars, you'll get the list of distribution. And if you look at your note catcher now, you know that in this case, we need normal CDF, which is number 2. So press number 2. Then here, we have to fill the information. Lower limit for our area in our example is negative 1.03, negative 1.03. upper limit for the area is 1.64. 1.64. I need a mean of 0. That's what I have. Standard deviation 1. That's what I have. Now paste this in the main screen, and you'll see what you have written in your node catcher. We have written normal CDF, negative 1.03, comma 1.64. Mean is 0. Standard deviation is 1. Hit enter to get the result. So if you hit enter, you'll get 0.7980. So that is the area between z equal to negative 1.03 and z equal to 1.64. So from the calculator, we got the area between these two values as 0.7980. Remember one thing, the area under the normal curve is also the probability. That means we can also write this one like this. Probability that is z value is between those two, between negative 1.03, okay, z is between negative 1.03 and 1.64. That is the meaning of between. You can see z is more than that and less than that. So z is in between these two values is equal to 0.7980. So probability that z is between these two values is 0.7980. So the area and the probability under the normal curve are the same thing. Now let's work on part B. In part B, we have to find the area to the right of z equal to negative 1.36. So here we are talking about the standard normal curve or normal distribution. Meaning of that is you have the mean in the middle, which is equal to 0. So this mean is equal to 0. Now we want area to the right of z equal to negative 1.36. 0 is here, so negative 1.36 should be somewhere there. So here we'll have z equal to negative 1.36. We want to find the area to the right. Right means this side of z. So I want to find this area. So we are looking for this area here. Area to the right of z equal to negative 1.36. Now, we have labeled that area. This is the area A that we want to find. But if you look at the lower and upper limit for the area, because you know that in order to find the area, we'll be using this command in our calculator, normal CDF, lower limit for the area, lower limit, the area starts here, upper limit, now the area goes from here all the way up to positive infinity. This side, if it goes all the way up there, that is positive infinity. We don't have infinity in our calculator, so what we do is this upper limit, which goes up to infinity, for infinity in our calculator, we write E99. E99, this is how we write infinity. For positive infinity, E99. If it is negative infinity, we'll do negative E99. But here we have positive infinity. So the upper boundary for the area is E99. And you already know that mean is 0 and standard deviation is 1. So what we'll be using in our calculator is this. Area A is equal to, same command, normal CDF in our calculator, normal CDF. The lower boundary for the area is negative 1.36. Upper boundary for the area is the infinity, because it goes from here all the way to that end, that is infinity. We write infinity as E99. Then we need the mean and the standard deviation. Mean is 0, standard deviation is 1. Mean 0, standard deviation 1. Now we are going to type this in our calculator to get the result. Let's see how we can use our TI-84 calculator to type this and get the result. Now in TI-84 calculator, we go to second, and then we go to vars. That's where we access our distribution. We are looking for the second one, normal CDF. So number 2, normal CDF. Now I need the lower limit of our area. In this case, or in part B, the lower limit is negative 1.36. This is the negative 1.36. And then here we type the upper limit. And in this case, the upper limit is infinity or E99. Now look at the screen carefully. In order to get that E, we press second and this comma. If you press second and comma, you'll get E. 99, that's infinity. Second and comma will give you E and then type 99. That is the positive infinity. Mean is 0. Standard deviation is 1. Now paste that information on the main screen. This is what we have written in our note catcher. Normal CDF, negative 1.36, E9901. Hit enter and you get the result 0.9131. So that is the area to the right of Z equal to 1.36, negative 1.36. So from our calculator, we got the area that is equal to 0.9131. Now we can write this in probability form, which is same as probability that the Z value is to the right of this. That means more than, Z value is more than negative 1.36. Z is greater than or sometimes equal to negative 1.36. Technically, Z is greater than negative 1.36 is equal to, greater means to the right, is 0.9131. 0.9131. So that's how we can write the same result using the probability form. Now part C, we have to find the area to the left of Z equal to 1.65. This is the standard normal distribution. So your mean is in the middle, which is equal to 0. Now 1.65 is on the right. Maybe somewhere over there is 1.65. So let me look at that. Suppose this point on the x-axis is Z equal to 1.65. We want to find the area to the left on this side, to the left of 1.65. So we want to find the area to the left of 1.65. We want to find this area. We can label that area by A. So let me do that. So we want to find that area A, which is on the left of Z equal to 1.65. We are going to use the same command here, area for part C. Area A is equal to normal CDF. Now the lower limits. This area goes from here, that's from the negative infinity up to 1.65. So the lower label is negative infinity, that is negative E99. So negative E99. Upper limit is 1.65. Mean and standard deviation 0 and 1 because this is the standard normal distribution. And we are going to type this in TI-84 calculator to get the result. Now in TI-84 calculator, we go to second, then vars here to access the distribution. And I'm looking for the normal CDF, so number 2. And we are going to fill this information here. The lower limit in this case is negative infinity. So for negative, we use this. Infinity, we do E99. If you press second and comma, you'll get E, then 99. That is the lower limit. In this case, the upper limit is 1.65. So 1.65 is the upper limit. Mean is 0. Standard deviation is 1 because this is the standard normal distribution. Paste this information in the main screen. So this is what we have written on paper. Normal CDF, negative E99, 1.6501. Hit enter to get the result, which is 0.95 0.05. So that is the area to the left of z equal to 1.65. So from the calculator, we get this area equal to 0.9505. We can also write this in probability form like this. Probability that your z score is less than, because it is on the left, so it is less than 1.65. Z is less than 1.65. You can also do less than or equal to. That is equal to 0.9505. So probability that z is less than 1.65 is 0.9505. So always remember, the area under the normal curve is also equal to the probability.